This video shows you how to run the paired bootstrap test. If you use the age stage, choose X life table theory to analyze your data and use the bootstrap technique to estimate the variances and standard errors of population parameters, you can easily use the paired bootstrap test to detect whether there is significant difference between two treatments. Once you have completed the raw data analysis of life tables of different treatments A1, A2, and A3, you can use the paired bootstrap test to assess the differences of all parameters among them. Note well, if you plan to use paired bootstrap test, you must use the same number of bootstrap resamplings for the life table analysis of all treatments. In order to get reliable and stable results, B is equal to 100,000 is suggested. Important: you must write a short treatment code. The value must be less than or equal to 6 characters in the third line of life table data files. The code is an abbreviation of your treatment. You can write more detailed information about your data in the first or second line. A good code allows you to identify the data quickly. For example, DBM25C can be life table of diamondback moth collected at 25 degrees Celsius. BALC20 can be life table of Bemisia argentifoli treated with LC20. PM28C can be used to represent life table of Pierococcus marginatus collected at 28 degrees Celsius. This slide shows the logic of paired bootstrap test. You analyze life table of treatment A using bootstrap technique with 100,000 resamplings. Because the bootstrap technique is random sampling with replacement, the bootstrap result varies from time to time. The 100,000 estimates are not sorted. Then you analyze life table of treatment B in a similar way. The 100,000 estimates are not sorted, too. When you use the paired bootstrap test in TrueSeq's program, it will calculate the difference of the first estimate of treatment A and the first estimate of treatment B. Then it will calculate the difference of the second bootstrap estimate of treatment A and the second bootstrap estimate of treatment B. There will be in total 100,000 differences. They are unsorted. The TrueSeq's program then sorts these 100,000 differences to find the 0.0 to 5 and 0.975 confidence intervals. In the plot A of this slide, you can see the 100,000 bootstrap estimates of the net reproductive rate of treatment A. They randomly distribute around the bootstrap mean. The dashed line are used for points to show the randomness. The first estimate, the yellow point, it is greater than the mean. The bootstrap estimate of the y point is slightly higher than the mean. The pink and red points are lower than the mean. In the plot B of this slide, you can see the 100,000 bootstrap estimates of the net reproductive rate of treatment B. Similarly, they randomly distribute around the bootstrap mean. The first estimate, the yellow point, is less than the mean. The bootstrap estimates of the white and pink points are both less than the mean. But the red point is greater than the mean. The 100,000 differences of plot A and B are shown in plot C. In this slide, you can see the distribution of sorted differences of these two treatments. The black line is the zero difference. The red line is the lower confidence interval limit, that is 0.0 to 5 percentile. And the blue dashed line is the upper confidence interval limit, that is 0.975 percentile of the differences. The zero line is outside of the confidence intervals. If the confidence interval does not include zero, there is significant difference. Once you have completed step A3, there are many files ready for the paired bootstrap test. You can identify them with the effect boot in the file name. If your life table data file is named as x.txt, there will be following bootstrap result files. For example, x_effect boot, a1a, r0.x_effect boot, a2a, r, and x_effect boot, a3a, lambda, etc. Note well, please don't use files have the extension with SN. SN means serial number. They are for figures of random distribution of bootstrap results. If you want to run the paired bootstrap test, click on C, pair BT. At first, you have to enter the number of treatments. If there are 4 treatments, then enter 4. Then you can pick the files you want to compare one by one. For example, if you want to compare the net reproductive rate of different treatments, you have to pick affect boot A1A R0.txt. At the upper left corner of Open File dialog, the yellow arrow, you can see which treatment you have to pick. When the paired bootstrap test is completed, you can see the following screen. The detailed results are listed in the file 24_result. You must read this file carefully and mark the difference in the appropriate tables of your paper. The table you see on the screen is the differences between treatments and p-value. The mean difference between BHXS and BSL is 0.757. The p-value is 0.7781. The difference between BHXS and BSL is not significant. The mean difference between BHXS and CB is 5.92. The p-value is 0.003. There is significant difference between BHXS and CB. In the file 24, you can see the detailed results of paired bootstrap test. Because it is a paired test, there are detailed information about each pair. The original values are the parameters calculated in step A2. In this slide, you can see the comparison between BHXSR0 and BSLR0. The original net reproductive rate of BHXS is 7.538, and the net reproductive rate of BSL is 6.789. The red difference 1 is the difference of these two original values. The difference is 0.74899. The blue bootstrap means are the means of 100,000 bootstrap results. They are 7.54869 for BHXSR0 and 6.79158 for BSLI0. The blue difference 2, 0.75710, is the difference of true bootstrap means. The green difference 3 is the mean of all 100,000 paired bootstrap differences. In general, with the increase of B, the blue difference 2 and the green difference 3 will close to the red difference 1. In general, you need to report the confidence interval and p-values in your paper. The results of paired comparison are presented in 3 ways. 1. The t-confidence interval. 2. The percentile confidence interval. And 3. The probability of insignificant differences among all bootstrap samples. In this slide, the lower t-confidence interval of difference of BHXSR0 and BSLI0 is negative for 0.495. Thus, the confidence interval includes 0. There is no significant difference. The lower confidence interval of percentile confidence interval is negative for 0.538. It also shows there is no significant difference. The number of insignificant differences is 77,808. The p-value is 0.77808. It is greater than 0.05. It shows there is no significant difference. If the lower confidence limit is negative, it means the confidence interval includes 0, and there is no significant difference between these two treatments. In this slide, you can see the comparison between BSLI0 and CBI0. The original net reproductive rate of BSL is 6.7894, and the net reproductive rate of CB is 1.6263. The red difference 1 is the difference of two original values. The difference is 5.1631. The two blue bootstrap means are the mean values of 100,000 bootstrap results. They are 6.7883 for BSL and 1.6281 for CB. The blue difference number 2, that is 5.1602, is the difference of true bootstrap means. The green difference 3 is the mean of all 100,000 paired bootstrap differences. In general, with the increase of B, the blue difference 2 and the green difference 3 will close to the red difference 1. In this slide, the lower t-confidence interval of difference of BSL and CB is 1.2747. Thus, the confidence interval does not include 0, and there is significant difference between BSL and CB. The lower confidence interval of percentile confidence interval is 1.5418. It also shows there is significant difference. The number of insignificant differences is only 969. The p-value is 0.00969. It is less than 0.05. It shows there is significant difference. If the lower confidence limit is positive, it means the confidence interval does not include 0, and there is significant difference between these two treatments. In Table 2, you can see the differences and lower confidence limit for all comparisons. The upper right triangle, the red triangle, are the differences between treatment I and treatment J. The lower left triangle, the blue triangle, are the lower confidence limit of difference between means of treatment I and J based on t-distribution. The star shows significant difference. In Table 3, you can see the differences and p-value for all comparisons. The upper right triangle, the red triangle, are the differences between treatment I and treatment J. The lower left triangle, the blue triangle, are the p-value of difference between means of treatment I and J based on t-distribution. A p-value less than 0.05 is marked with a star. It shows significant difference. In Table 4, you can see the p-value and differences of all comparisons. The upper right triangle, the red triangle, are the p-values between treatment I and treatment J. A p-value followed by a star means significant difference. The lower left triangle, the blue triangle, are the difference between means of treatment I and J. A difference followed by a star represents significant difference. Table 5 is similar to Table 4. In the last column, the original values are listed for your convenience. Table 6 are the p-values of all paired comparisons. Table 7 contains the original means and bootstrap standard errors of all treatments. You can use the following table to mark the differences between treatments. Only the differences between the first few treatments are marked for you. Note well, if this table is not completed, you have to complete the rest blanks yourself. This is a good practice of critical thinking. Thinking is the most important thing in science. In this slide, you can see the concept of the paired bootstrap test. If there is significant difference between treatments, the distributions of the bootstrap estimates are not overlapped or with small overlap, and the lower confidence limit locates to the right of the red zero line. In other words, the confidence intervals of all 100,000 differences does not include the zero line. However, if there is no significant difference between two treatments, the bootstrap estimates of two treatments will be overlapped in the red zero line located to the right of lower confidence intervals limit. In other words, the confidence interval of 100,000 differences includes the zero line. Attention! You should not use routine statistical functions in SAS, SPSS, or Excel to analyze or compare the bootstrap output files created by A3. Bootstrap. You can, however, use programs designed specifically for bootstrap technique to carry out advanced analysis of these data files. If you use TwoSix program to analyze your data and use the paired bootstrap test in your research, you must cite following references. If you want to use the paired bootstrap test for a specific parameter, but TwoSix didn't prepare the file for you, what can you do? For example, if you want to compare the eggs laid by female per oviposition day, you can use the following file to run G, general bootstrap, xgxprod for general bootstrap. You will get the following file for paired bootstrap test. xgxprod for general boot 0gb0 results for pt 1 by 1. If you want to use the paired bootstrap test for a specific parameter, but TwoSix didn't prepare the file for you, what can you do? If you want to use paired bootstrap test to compare the pupil weight, you can prepare the pupil weight data file according to the format of xgxprod for general bootstrap. Thank you very much.